Hey everybody, how you doing? Welcome to What Up Plays channel. We talk about all kinds of things, how to build it, how to fix it, how to maintain it, or product reviews, or anything that comes across my desk. As some of you know that have been following my channel, lately I've been doing a lot of testing and comparison with these 5 motors here. These motors are for RC racing. These are 17.5 turn motors. They're brushless motors. They're probably some of the more popular brands that are out there. But yeah, just giving an idea of how these 5 motors here compare with each other. I have the Surpass Fat Boy here. This is stock spec 17.5T, the V6. This right here is the Surpass V6 17.5 lightweight. This right here is the Trinity slot machine, certified. It's a 5%er. This is the slot machine here. This is just a regular stock spec. You can tell by the end bells, the certified is black, the stock spec is the purple, and then we have the RPM master right here, the Helix RS 17.5. This is just regular stock spec. There's nothing. The only one here that's certified motor is the slot machine here. Now this my final test on these things will be testing how efficient these things are under load. And how I'm going to test that is I'm going to be using the WMH Racing, put this way it makes it easier to read, right there, WMH Racing Loadmaster. What this is, this connects to a Hobbywing tunalizer or a Trinity motorizer, and it helps test the motor while under load. Runs through these resistors here. You can watch a video. I'll put a video out how this thing works, and you can see how it works. So, all right, let's go get these motors together and let's learn something. Okay, so during this test, I'm going to use a Surpass V6 lightweight motor. I'm going to use this as a slave motor. This is the one that's going to be generating the load on the other motors. This right here is the first motor I'm going to test, is going to be the Surpass stock spec motor. We'll try that one first. I've already pre-tuned these things. They're all basically between 5 amp and 6 amp without a load. I'll go ahead and put this in here. You can see how I love this holder for testing motors and stuff. It just snaps in place. Make sure the tabs are lined up. Plug the sensor motor in, or sensor plug in. If I can. But wow, that was tough. Anyhow, give you an idea without a load. Without a load, it's running 5.35 amps. Has an RPM rating of 22,300 or 22,400 kV of looks like 3135. We're doing a test here. See here, it's 3117. And there's in-bell deviation, rotor symmetry, and then the Hall signal deviation. Motor temperature doesn't matter. So that's what the motor is without a load. So let's go ahead and hook up the slave motor and see how well it does with the slave motor on it. Okay, so I'll go ahead and run this. As you can see here, I am using the 1 ohm resistors for this test. So let's go ahead and run it. Okay, we're running at 11.6 amps, 28, 41, 47 in the kV, and bell timing went to 45, 1.9, 0.3, 2.8. Alright, let's check the RPMs and see what the RPMs are at. So it's about 20,800 RPMs. Alright, let's input this data and then we'll switch over to the next motor. The next motor I will test will be the Surpass Lightweight. Alright, as you see here, I have the Surpass V6 17.5 lightweight motor. I'm going to run it first without a load on it. I tell you what, I love this thing. If you have one of these motor testers, motor analyzers, you have to get one of these WMH racing motor mounts. They have just the mount where it's not all this over here, it's just the mount. All you do is just clip your motor in, pop your motor out. It has little metal tabs on there on the inside. Thing's awesome. Don't have to use alligator clips anymore. Don't have to worry about shorting out. But, alright, let's run this thing without a load, see what it does. Alright, current, we have 5.67. kV is 3157. And bell time is 52.6, 51.9, 52.3, 37. Okay, now let's see what we have over here. See, these numbers are really low. That goes to show how well this motor right here is made. These Surpass motors, these V6s, are pretty good. And so you guys are aware, the Surpass V6 motors are now Rotor approved. They have been approved by Rotor. So you can use them in all Rotor sanctioned type events. Anybody who follows the Rotor rules. So let's go ahead and see what we have on the RPM side. Looks like the highest I got was 23,000. What is that, 23,600? We're going to run around 22,500. Okay. All right, let's pop the load motor in. You tighten these things down, and then we'll run this one under a load. Alright, it's all set in there. Let's go ahead and kick this thing on. Let's run a test mode here. That's loud. Alright, here's what we have here. We have an amp current draw, an amp draw of 12.04. kV of 2896. And the end bell time is 49.6. See if any other numbers change back here. Yeah, they changed a bit. We have a 0.5, 2.7. So I'm just inputting this on my spreadsheet so everything's recorded. All right, let's go ahead and run this thing and see what the RPMs are on it. Looks like we get about 27,000 or 20,747. So about 20,700 RPMs. Okay. Let's see, the next motor we test, let's say we test the, how about we test the slot machine stock spec. Let's slap that boy in there and see what it can do. All right, I have the Trinity stock spec motor here. Go and plug the sensor plug into this one. Plug that thing in. Everything's all lined up good. All right, let's do a non-load run. All right, here we have the numbers. You have a 5.54, 3216, and 51.7 degrees. Right here is the M-bell deviation. And the rotor rate symmetry, Hall signal deviation, and motor temperature. All right, let's go ahead and run the manual. See if we get in the RPM range. See what the high RPM is on this. Looks like we get about 24,000. About 24,100. All right, let's go ahead and put this thing under load and see how well it works under load. Okay, I got the check my resistors, make sure they're not hot. They're still room temperature. I got the everything locked and loaded. Let's go ahead and run the test. All right, here you have the numbers. Current is 12.13, kV 2945, inbuilt timing dropped down to 49.2. All right, let's see what we have here for the inbuilt deviation, rotor symmetry, Hall signal deviation, and the operating temp. So, all right, let's go and look at the RPMs. You know what? I noticed that voltage right there is dropping. That's going to change the RPMs on this thing. So, just want to make it fair, make sure everything's running at 7.4. I'm going to swap out the battery real quick. The batteries I am using are the red lines, 4,000 amp hours. That's why I'm having to switch this thing out so often after only a couple motors. But yeah, that's what I'm using. I'm using these batteries here. So, all right, let's go ahead and have a brand freshly charged battery on here. Let's go ahead and do this again. Doing the RPMs now. Look like 21,700. I'm gonna go ahead and run the auto one. Just running that again to make sure that the numbers are showing up as the same, which let's see here. Yeah, they're pretty much the same. Nothing's really changed. So okay. Now the next motor we'll run is the Trinity slot machine 5% certified. Let's see how good this thing is. This $160 motor here. All right, first off, I'd like to mention that there are thousands of racers out there. And along with having thousands of racers out there, there's going to be thousands of different opinions on what these numbers mean, different perspectives. So, with that being said, I'm going to give my personal perspective on these numbers, and if anybody has different perspectives, different opinions, by all means, put them down there in the comments. We'd all love to hear them. So, let's get into this. So here at the top, starting up from the top, we have the Surpass stock spec motor, 17.5. These are the V6 motors. Both these Surpass motors. This is stock spec. This right here is the lightweight. This right here is the Trinity stock spec motor. This one is the slot machine. This is the standard slot machine motor, the run-of-the-mill $100 motor. One below that is the certified 5% motor. These motors, well, let's get this one. Fantom, Helix RS 17.5. This is just a regular spec edition, stock spec. It's the regular $100 motor. Now, the price of these motors, price could have a big difference on what route you decide to go. You have the Rocket V6 motors here. I believe they go for somewhere around $80. You find them all day on eBay. You have the Trinity slot machine. This one here is about $100 for the regular one, the standard one. The certified one is $160 approximately. And the Fantom Helix, that one right there, runs about also about $100. Let's go to the motor weight over here. We have the stock spec Surpass is the 5.5 ounces. These are measured in ounces. Now you can tell this one, you know right off the bat, this one right here is going to be the heaviest one. It has the fattest can, the fattest stator on it. Then you have the other ones here. These are the rotor numbers that are found inside these motors. The Gauss, the V6 stock spec Surpass had the highest Gauss reading, 1763. The Surpass V6 and the Trinity certified, those two right there tied at about 1755. And then you have the Trinity slot machine standard one. Then you have the Fantom motor here. 1725. Over here you have the stator length. This is the length of the actual stator. The Surpass one would be 19.5, and then the other ones follow with the Trinity. These right here, 0.1 difference. I measured it multiple times to make sure, and yeah, it came up to where the certified one is 0.1 millimeters. These are all measured in millimeters here. 0.1 millimeter longer. Not sure why, not if it's a code, I have no idea, but that's what it is. The stator IR, this is the internal resistance. These numbers here I got from the Rotor Racing website. I believe it's roarracing.com. Not sure. I go on there and look at the motors that are Rotor certified. So you guys are aware, the Surpass V6 motors are now certified by Rotor. They are Rotor certified. So they're legit to use at all Rotor sanctioned events. So the IRs, these are all out of viewing all the motors on the Rotor site. These motors here probably have the lowest IR out of all the motors, all the other motors in the same class on that website that I've seen. The 35.4 being the lowest. Now the Trinity, the certified one, I didn't see one on there for the certified motor, but I'm sure it's going to be lower than the slot machine, the standard one. I'm sure Trinity gave it the stator that had the lowest IR. I don't know what it is, so I just put a Q. I don't even know what that is on there that I put. But so the stator diameter, the Rocket V6 stock spec, of course you can look at it and you can tell it's fatter than all the other ones. It's 35.8. Again, it is within Rotor limits because it is Rotor legal. That also explains why this thing has a lot of torque on it too. Fatter stator. These are the rotor weights. They're all the same except for the Fantom. The Fantom is 0.9 ounces, and yes, I measured multiple times and it is on a certified scale, the scale that I use for measuring refrigerant. 0.9 ounces versus 1.0 for the others. This right here is the date that I tested them in. The factory timing settings right here, and so on. Now let's get into the big meat of the numbers. But these right here, these numbers here are to be taken into consideration, especially the Gauss, the IR, and the stator diameter. So you got this one, this one, this one are huge for determining motors. They help you determine which ones has the most torque. Higher Gauss relates to what I've seen out there is more torque. Stator length also works with the different torques and all of this stuff. Stator IR, just more efficient motor, runs a lot more efficiently. Stator diameter, the fatter the stator, been known to give you more torque. Rotor weight breaks down RPM as well as torque, but a lot of it, most of it has to do with Gauss, in my opinion. So let's get into these here. Okay, now remember we have the Surpass stock spec on the top, Surpass lightweight the second, Trinity stock spec in this one. Trinity certified is the fourth one down, and the last one down here is the Fantom. They're not in any particular order for any particular reason. They're just how I inputted the data for each motor, inputted each motor in it. So with the tan line here, you see each motor has a tan highlight. The tan highlight is the timing adjustment that I adjusted all the motors to where I saw they were getting about the most efficient with the KV and and amperage and so on. The pink is when I did the load test. Pink or peach, whatever color you want to call this. So this is before the load test. This is during the load test. I did not change the timing or anything on the motor when I ran the load test. So here you see the timing's at 50.2. Well, under a load, the timing went to 44.9. So there's just so you see how the difference is between unloaded and loaded. The yellow just means that's another test I did where I added titanium screws and ceramic bearings and stuff like that to them. The Trinity motor, this one here, which is the stock spec, I ran this one loaded, fully dressed. It was, I kept the titanium screws in it for the can, for the timing end bell, and I kept the ceramic bearings in it, and so on. All the motors were shimmed. I shimmed them all to where they seem to be working the best. So, that being said, the number on the tan, the number on the pink, you see the difference, the current draw, the KV, the KVs, you see the difference how they changed under a load. Now, what I did is I took the difference. I did for example here, I did 11.57 amps, and I minused 5.29 amps, so that gave me a difference of 6.28. So if you look over here to the right, you'll see the numbers that I typed in to show the differences from loaded and unloaded. So here you have the V6 stock spec had the lowest difference in amp draw. And the second lowest would be the certified Trinity motor, and then closely behind was the lightweight, so V6 lightweight, and then you have the Trinity stock spec slot machine, and then you have the Fantom down at the load. Now the Fantom under load had the biggest differences. The numbers changed the most. Had the highest RPM drop, had the highest kV drop, had the highest amperage draw difference. However, if you look here, the RPMs on the Fantom loaded is still 22,300 versus the Trinity stock spec was 21,700. Why is the Trinity stock spec higher RPM than the certified? I think it has to do with the shimming and the titanium screws. Why do you pay $160 for a Trinity and it doesn't come with titanium screws and stuff? I have no idea. Seems me like for that type of money they should toss in the titanium screws. But moving on. So yeah, the Fantom has the highest RPMs. However, it has the least amount of torque. You see the difference of the drop of the kV and the increase in amperage difference. So that being said, you can add an extra tooth to the other motors and you'll get the same speed, RPMs out of the final drive, as you would with the Fantom. What I'm actually seeing out there is people are bumping up 1 to 2 teeth more on like the Surpass V6 than the Fantom. So overall, the Trinity certified motor had the least differences, least changes or increase or decreases from versus loaded and unloaded. So all right, let's go ahead and I'll go over the motors again, and I'll give you my final thoughts on them. Okay, so here's my final thought on it. As I mentioned in the video earlier, there's tens of thousands of racers out there, and there's going to be tens of thousands of different opinions on how the numbers are deciphered. So again, this is my personal view on it, and also from what I've seen from other people on the track who race these same motors. You have the fastest motor out there is the highest RPM motor is the Fantom. The one that had the least amount of changes when under load is the certified slot machine. The ones that showed to have the most torque and stuff like that is the Surpass V6, the stock spec. So, which one's the fastest for the track? A lot of it depends on what track you're on, what your driving style is, and what you prefer. Can you make it to the podium with any of these motors here? Yes, you can. It all depends on on how well you can drive and how well you can keep your car under control, how often you crash. But from the experience that I've had, and that I've also noticed with other racers, the V6 stock spec here, the big boy, the big fat boy right here, this was not the highest RPM motor. The RPMs on it was short by, well, it's about 2,000 RPMs less than this one, and it was actually about 1,500 RPMs less than this one, and a few hundred less than the others. But this one here, what I'm seeing is you can add a bigger pinion on it. So the bigger pinion on this one versus the other ones showed a great deal of difference. The torque on it still had plenty of torque. It was still keeping up on the straight lines with motors like the Fantom and stuff like that. But when you're jumping on it, it was able to hold the front end up in the air because you got the torque on it to accelerate off. Carpet race and stuff like that, you have the torque to get out of the corners and so on. Again, it depends on your driving style, a lot of it, and what track you're on. So yeah, that's my personal view on this. So if you like the video, you find it informative, please like and subscribe. I greatly appreciate if you hit the like button, especially. Therefore, the algorithm will send this video out to more people so that they can also see the differences in the motors. I'm going to acquire more motors in the future. I'll get more of the popular ones, maybe some hobby wings or something like that, and try and run those under the same numbers and same tests, and see what we do. But yeah, again, please like and subscribe if you like this video. If you didn't like this video, please like and subscribe anyway, just so you can make fun of me. Alright everybody, have a good night.